partial differentiation. So the partial differentiation are basically applied to the multivariable function. So basically two types of function. So you have the first type, which is called a single variable function. So a single variable function is basically what the function that you have been dealing with in the previous level, N5 and 4. So for instance, if I say f of x is equal to x squared plus 2x plus 1. So this is a single variable function. Why is it called single variables? Because if we look at the function here, we only have one variable. So the variable x, as you can see, we only have one variable. So now what is a multivariable function? A multivariable function includes more than up to two variables. We can have a function of two variables or more than two. For instance, if I say z is equal to x squared plus y squared, so that is a multivariable function. So it's a multivariable function that includes two variables. So you have x and y. So you have the function z that includes the variable x and y. So this is a multivariable function. So a multivariable function is basically represented by, so you can say, for instance, z is equal to f of x and y. So this simply means that we have a function z that includes x and y variable. So you can also have, for instance, z is equal to f of x, y, and maybe t. So this is also a multivariable function, but in this case we have, so in this case the function includes three variables. So now when we speak about partial differentiation, so these are basically the differentiation that are applied to the multivariable function. Okay, let's go to the to a single variable function. Okay, let's consider, for instance, this function here, f of x. So if we have f of x is equal to x squared plus 2x plus 1. So in this function we can't apply partial differential calculus. So cannot apply any operation on partial derivative because it is a single variable function. So if we need to derive this function, you will just say, okay, we can call that function as y. So y represents the name of the function. It's not a variable, but here we only have one variable, which is x. So you have y function, which is equal to x squared plus 2x plus 1. So the derivative for a single variable function is denoted as follows. So if we say dy over dx, so that simply means that we are deriving a single variable function. So that's gonna be 2x plus 2. But what if we have a multivariable function? Are we going to apply this notation? So the answer is no. So when we have a multivariable function, the derivative notation will change as well. For instance, let's consider this function. If we say z is equal to x squared plus y squared, they will never ask me to determine dz over dx. So this notation is wrong. So this notation is only applied to a multivariable function. So the correct notation can be this. So we are deriving the function with respect to x, for instance. So if you see this symbol here, so this symbol just tells us that the derivation is being applied to a multivariable function. So that's the difference. I'm sure you understand the difference between single variable function. The single variable function are basically the function that you've been applying in N5, N4, and so on. So now in N6 we have a multivariable function. So it's basically the function which are made of 2 or more than 2 variables, and then the derivative for multivariable function. So I mean the notation of derivation of multivariable function is different. So for a single variable we use this notation here. So if we say dy over dx, simply means that we are deriving the function y with respect to x. But as the function includes many variables, so that means we're going to apply another relation. So a relation that is used to derive a multivariable function. So we can have, for instance, dz over dx or dz over dy. But before you understand the derivative of multivariable function, just make sure that you are familiar with this formula sheet here. So these formula sheets are basically the one that you've been applying in the previous level, N5 and N4 and so on. So now to determine, they are used to determine to derive or integrate a function. So the first column represents the functions. So these are basically the basic function. So the second column are the derivative of this function. So if you have to derive this, you get that, and so on. And the list continue. You just have to make sure that you understand this formula, because we're going to apply this again for multivariable function. Okay, here's an example of a derivative of multivariable function. Okay, they give a function z. We have z which is equal to x squared plus 2xy plus y squared plus 3x plus 2y plus 1. So the first question is to derive the function z with respect to x. So as you can see, they are using this notation, which are basically applied to the multivariable function. They are not using dz and dx. So this is wrong. So the reason is simply because we have a multivariable function. So here the trick is To derive this function with respect to x, you just need to treat your y as a constant. All the y that you see in the expression, you just treat them as a constant. So for instance, in this function, we have x squared that can be derived. So if we derive this function with respect to x, so if we derive this, we get 2x, and then we have plus, and then this is the second term. We know that the second term includes two variables, but as we are deriving with respect to x, we need to treat the second variable, which is y, as a constant. It's like they are asking you to derive this. So we have 5k x. So all you need to do is, or if you say 5k to the power of x, I mean 5k x to the power of 2, for instance, you can easily derive it because k is a constant and 5 is also a constant. So all you need to do is you just consider your x, you just derive your x. So the derivative of x squared give 2x. So you actually have 5k multiplied by 2x, and that gives 10kx. But same thing here, but I will actually call my k, which is y. So like in this case, y is a constant. So all I need to do is I'm going to consider the x only. If I derive x, I get 1. So the derivative of x gives 1. So 1 multiplied by 2 gives 2. 2 multiplied by y, which is a constant, so I'm going to have 2y. And then I have the third term, which is y squared. So what is the derivative of y squared with respect to x? Because all this represents a constant, and I know that the derivative of a constant is 0. So if I derive y squared, I'm gonna get 0, since we are deriving the function z with respect to x. So therefore, if I derive y squared, I will end up with 0. And then here I have 3x plus, so here I have 3x because we are deriving the function with respect to x. So all I need to do is I just need to derive 3x. When I derive 3x, I get 3. And then 2y is a constant since we are deriving the function with respect to x. So that's gonna give 0. And then 1 is also a constant. Doesn't matter whether we are deriving with respect to x or with respect to y. So this one still gives 0. So in other words, the derivative of z with respect to x is equal to 2x plus 2y, and then you also have 3. So you have 2x plus 2y plus 3. So this is, so that's the answer. So the second sub-question is to derive the function z with respect to y. So I have the same function, which is z is equal to x cube. So here we actually have x cube, not x square. So if we derive x cube here, we are going to get, so we bring the exponent down and then we subtract 1 in the exponent. So we actually have 3 to the power of 2 there. So we'll end up with 3 to the power of, so we have 3x to the power of 2. So here we have 3, not 2. So now what's gonna be the derivative of the function z with respect to y? So this is the notation. So in this case, you will now treat your x as a constant. So if you look at the first term, we have x to the power of 3. So the derivative of a constant here gives 0. And then you go to the second term. So the second term is made of x and y. Okay, all this can be considered as a constant because we are deriving the function with respect to y. So we are going to consider x as a constant, and there is another constant in front of x. So I will just consider the whole thing as a constant. It's like they are asking me to derive this. We have ky. So what is the derivation of ky? So that gives k. So in other words, if I derive 2xy, I'm gonna end up with 2x because I'm deriving my the function z with respect to y. So the second term here will be 2x. So now what's gonna be the derivative of the third term? So we're still deriving the function z with respect to y. So if I derive this term, I'm gonna get 2y. So you just need to bring the exponent in front and then you subtract 1 from the exponent. And then here we have 3x. So all this can be treated as a constant. So the derivative of a constant is 0. So you don't even need to write it. And the derivative of 2y gives 2. Remember, we are deriving the function with respect to y. So that's going to be the solution to this question. So this is the solution to the question. Okay, now let's look at this question here. We have the function z is equal to 10 x squared y plus sec x y squared. So we need to derive the function z with respect to x first. So in other words, we need to find this. So here you can see that we have the first term and the second term. So we need to derive the first term with respect to x plus we apply the derivative of to the second term again with respect to x. So if we derive this, we'll actually get, so So first need to derive that part here, and then we know the derivation of 10. If we derive 10, we're gonna get, so we have to derive that, and then we multiply by sec of, so I need to add sec square, and then we have x square y. So this is only the derivative of the first term. The first term is this one, and then we say plus. We also need to apply, we also need to derive the second term. What is the derivative of sec? Okay, before I do the derivative of sec, I'm gonna explain you where I get this. So it came from the formula sheet. So if you go over the formula sheet, you look at the derivative of 10 is equal to f of x. So all you need to do here is, so you are actually applying this formula to the first term, because we have a 10. So the derivative of 10 of a function gives, all you need to do is, you first write the sec square of the function, and then you multiply by the derivative of the function. So this is basically what I did to the first term. Okay, I'm gonna repeat this here. So this first term is 10x squared y. So we can treat x squared y as a function that we can call f. It's like they are asking me to determine the derivative of 10 of the function f. So that gives, according to the formula, we first need to write sec square of the function f multiply by the derivative of the function. So this is what is given in the formula. So this is basically the same. The reason why I don't like to write f of x, because here we have a multivariable function. I mean, here we have a single variable function, but there we have a multivariable function. So if I say f of x, so it's like my function is a single variable while we have a multivariable function. So now I'm going to apply the same principle here. So I have 10x squared multiplied by y. So all I need to do here is I first need to derive the function. The function is x squared y, and then I multiply by the square of the function. What is the function? The function is still x squared y. So now I'm gonna have to derive this part, and when I'm deriving, I need to make sure that I'm deriving with respect to x. So in other words, I'm gonna have to consider to treat my y as a constant. So I only care about x squared. So if I derive x squared, I'm gonna get 2x, and then y is a constant, I will just add it, and then I have sec square x square y. So this is just the derivative of the first term. So now I need to look at the formula of the derivation of sec on the formula sheet. So first include the plus sign here, and then I go again to the formula sheet. So from the formula sheet I can say that I have the derivative of sec of the function. So it gives me that. So all I need to do is I just need to apply this formula here. Okay, now let's go to the next function. So in this question they want us to determine, okay, they say given f of xy, so this is a multivariable function which is made of x and y variable, and the function is given by x to the power of 3y multiplied by e to the power of xy. So this is a multivariable function, and they want us to determine f x 1, 1. So what does it mean? So if they say f x, so it simply means that they want us to derive this function with respect to x. So now if they add this number, so this is basically a point which is made of x, the x value which is 1, and the y value which is also 1. So it simply means that you first need to derive this function with respect to x, and then you replace the x value and the y value, and then you compute. So the first step is to derive the function. So you have the function, so you have to derive this function here with respect to x. So this is the same as f x. So they simply want you to derive this function with respect to x. All you need to do is you're gonna have to treat your y as a constant. Okay, the function is x cubed multiplied by y to the power of e xy. So how can you derive this function? This function is, you can say that it is made of the product. To derive this function we need to apply the derivative of product. So the formula that is used to derive a product of two functions. So if you remember from the previous levels, basically in N5, so if you have a function j of x that multiply another function f of x, so now if they want you to derive the product of these two functions, so it's gonna give us, so all you need to do is you first derive your g of x, and then you multiply by f of x, and then you say plus so the second term will be, so you have g of x, and then you multiply it by the derivative of f of x. So I'm going to apply this formula. Why are we applying this formula? Because in this expression you can see that it is basically made of, we can write it in such a way to have two functions. All I need to do is, if I separate this into two, so I have my first part that I can consider as my first function, which is j of x, and then the second part can be considered as f of x so it means that I'm actually deriving the product of g of x and g of x multiplied by f of x. So all I need to do here is I just need to apply this formula. So therefore the derivative of this multivariable function with respect to x is gonna give me, so all this represents the function g of x. So all I need to do here is I'm gonna have to apply the derivative to g of x, and then I multiply it by f of x. F of x in this case is e to the power of xy, and then I say plus g of x. So in this case g of x is x cubed multiplied by y. So I have x cubed multiplied by y, and then f of x need to be derived again. So I have e to the power of x y, which need to be derived. So now, since we still have that this dash symbol, so that means I need to continue. So I need to derive this part here with respect to x. So in other words, I'm gonna have to treat my y as a constant. So I will only focus on the x cube. If I derive x cube, I get 3x squared, and then I multiply by y because y is a constant. And then I have to repeat e to the power of xy, and then I say plus. I have to repeat this because I have to repeat this bracket because it doesn't have a dash symbol. And then the next thing is to derive the last bracket. So what is the derivative of a function e to the power of a function f of x? So that gives, you first need to derive f of x, and then you multiply by e to the power of f of x. So I'm sure you can see that in the formula, but here we have a multivariable function. So in other words, if we derive a function e to the power of f, so we're gonna have to derive f first, and then you multiply it by e to the power of f. So if you go back to the formula sheet, okay, let's take time to see this formula here. So we are actually looking at this formula here. So if you derive e to the power of a function f, all you need to do is you repeat e to the power of that function, and then you multiply by the derivative of that function. So this symbol simply means derivative. So if I say e to the power of f multiplied by the derivative of f is the same as e to the power of f multiplied by, so the derivative symbol can also be written as we derive the function f of x with respect to x. So it doesn't matter. So now here we're gonna have to derive this function with respect to x, meaning that we are going to treat y as a constant. Okay, all you're gonna do is you first repeat the function that we have, which is e to the power of xy. If we apply this formula, so you have e to the power of the function, you repeat that, and then you multiply by the derivative of the function. So it means the exponent, so you derive the exponent with respect to x. So you have to derive this with respect to x. So you'll actually have, so copy the first term, and then we have plus x to the power of 3y multiplied by e to the power of xy multiplied by, so we have to derive xy with respect to x. In other words, we just need to focus on x. So when you derive x, you get 1. So 1 multiplied by y gives y. So just have y there. So we actually have 3x square y e xy plus, so I can remove the bracket, so that gives, and then we have 2y, so this gives y square. So we have x cube y square multiplied by e to the power of xy. So now, since they want me to determine fx 1, 1, so I just need to replace the value of x by 1 as well as the value of y by 1. All I need to do is I'm gonna have 1 squared multiplied by 1 to the power of e to the power of 1 multiplied by 1 plus 1 cube 1 squared multiplied by e to the power of 1 times 1. So you can get, if you solve this, you'll get 3e plus e, so that gives 4e. So now in the second question, they want us to determine fy of 1, 2. So in other words, we're gonna have to derive the same function but with respect to y, and then we'll replace the value of x by 1 and the value of y by 2. So all I need to do here is, okay, we have the formula, everything. So I'm going to derive the function fy with respect to y first. So I've already divided this function into g of x and f of x. So you have the first part, and the second part is xy. So again, if we derive, we'll still get the same expression. So we're gonna have to derive, so we first derive g and then we multiply by f of x, and then we say plus, so repeat the g function, and then we derive the f function, which is e to the power of xy. So this is basically the same as what we did in the previous sub question. So now the trick part is here. When it comes to derive a function with respect to y, in this case we are going to focus on the y variable, not on the x variable. So we are going to derive y, and then we're going to treat x to the power of 3. We're going to treat that as a constant. So if we derive y, we get 1 multiplied by x to the power of 3 gives x to the power of 3, and then multiply by, so we have that term here, which is xy, and then we have plus, so repeat this because we repeat this bracket because it doesn't have a dash symbol. And the next part is to derive e xy with respect to y. So I'm going to apply this formula again. So we need to know the derivative of e to the power of a function. So that gives, so first need to repeat e to the power of f, and then you multiply it by the derivative of the function. So the function is xy. So all you need to do here is you repeat e to the power of the function, which is xy, and then you multiply it by the derivative of the function xy. But when it comes to derive this function, you need to make sure that you are deriving with respect to y. So meaning that you're gonna treat x as a constant. Okay, here I'm gonna have to copy everything that we have. And then if we derive y, we get 1, the derivative of y gives 1, and then 1 multiplied by x, 1 multiplied by the constant x gives x. So you need to multiply it by x. So this is what we have here if we only derive. So now after that, the next thing is to replace the point that is given into this expression here. So when I say that f y 1, 2 is equal to, you just need to replace x. So the first number represents x and the second number represents y. So the value of x is 1, so you have 1 to the power of 3 multiplied by e to the power of, so the value of x is 1, and then y is equal to 2, so we have 1 multiplied by 2 plus 1 to the power of 3 y, which is equal to 2 multiplied by e to the power of x, which is 1 multiplied by y, which is 2, and then we multiply it by x, which is 1, and then all you need to do is just compute this part. So you have e to the power of 2 plus, so you have 1 to the power of 3, 1 multiplied by 2 gives 2, and then we have e to the power of 2. So if you add up these two terms, you get, so you have e to the power of 2 plus 2 e to the power of 2. So that gives 3 e to the power of 2. So the reason why we get e, because we have e to the power of 2, which is a lap term. So the first e to the power of 2 has a coefficient of 1. So if we have the terms, if we add 2 lap terms, so just need to look at the coefficient. So you have 1 there and 2 there. So 1 times 2 gives 3, and then you repeat e to the power of 2. Okay, that's it. Okay, let's look at the last question. So they want us to get, well, it's a given w, which is equal to square root of x squared plus y squared plus z to the power of 2. So they want us to determine the partial derivative of the function with respect to x. So that's the first question. So in this case, we have a multivariable function which is made of 3 variables. So we first need to determine this, the derivative of y with respect to x. And then next, I'm gonna replace the value of x, y, and z by their values. So now, in order to derive this, you need to use the formula sheet. We need to know the derivation of a square root of a function. So if we derive this, what are we gonna get? So we're gonna get, it's like they are asking you to determine the derivative of f to the power of 1 over 2, because f to the power of 1 over 2 is the same as square root of f. So that is, you can also use this formula. What is the derivative of f to the power of n? All you need to do here is you first bring your n down, and then you repeat your f, and then you have the exponent there, your minus, and then the next thing is to multiply by the derivative of the function. So in other words, if we have f to the power of n, we have to find the derivative of f to the power of n. All you need to do is, we have n multiplied by f to the power of n minus 1 times the derivative of f. So I have so that w can be written as f or square root of f, because if I consider everything within a square root sign, within a square root sign I have x squared plus y squared plus z squared. So that is the same as f to the power of, but in this case the value of n is 2. So if I have to derive w, So I can say the derivative of w with respect to x. So that gives, so I need to bring the exponent down, and then I have my function f. So in this case the exponent is 1 over 2. So I actually need to bring 1 over 2 down. So I have 1 over 2 multiplied by f to the power of 1 over 2 minus 1, and then I multiply it by the derivative of the function. So that f simply represents what is within the square root sign. So in this case I first need to derive so that f represents everything that is within the square root sign. So you have x squared plus y squared plus z squared to the power of 1 over 2 minus 1. So that gives negative 1 over 2. And then I'm gonna have to derive the function that is within the square root sign. So we have, in other words, we have to derive this. But when you derive, make sure that you are deriving with respect to x. So you first copy everything. So you copy everything that don't have the dash symbol. So now the problem is here, and this step is the one that's gonna differentiate all other different type of derivative. So if we need to derive it with respect to x, we'll just treat y and z as a constant. So we only focus on the x. If we derive x squared, we get 2x. And then what is the derivative of y squared? But we are deriving with respect to x. So here we have 0. So same thing, if we derive z squared, we get 0. In this case, we don't have to repeat it as we did in the previous, because these values are not attached to x. If they are attached to x, then we're gonna have to repeat that. It's like if we have a constant multiplied by x, and then what's gonna be the derivative of x? So I will just repeat the constant as it is. But if I only derive the constant which is not attached to x, I will get 0. The derivative of a constant always gives 0. So this is a constant and this is also a constant. So that means if we derive these two, we get 0. So we only consider the first term. And the next thing is to replace the values of x, so the value of y and the value of z, and afterwards I'm gonna have to compute it. So in other words, if we have to determine the derivative of w with respect to x of 1, 1 and negative 2. So all we need to do is replace the x value, which is 1, so we have 1 to the power of 2. The y value is negative 2, So you have -2 to the power of 2, and the z value is 1. So we have 1 to the power of 2, which gives, okay, if you can face, you can just leave it as it is. And then we have -1 over 2. And the next part is we have 2 multiplied by x. 2 multiplied by x. In this case, x is equal to 1. So 2 multiplied by 1 gives 2. So all you need to do is you just simplify this. I mean, you just compute this, and then you get a number. So like in this case, we're gonna have 1 square gives 1, and then -2 square gives 4. 4 plus 1, 5. 5 plus 1, 6. So we have 6 to the power of -1 over 2, and then multiply by that 2 here. So these two can cancel, so you are going to remain with 6 to the power of -1 over 2. So this is the same as square root of 1 over 6. So the square root of 1 over 6, so we can work this out quickly. Yeah, you can also convert that in decimal. So you get 0.4. So maybe they can specify in the program the number of the decimal place. So in the next question, you are going to derive the same function but with respect to y, and you are going to use a different point. So I will just show you what to do here, and then you can continue. So there are also some questions that I'm gonna give you to solve. Okay, so we'll first do the same thing as we did in the previous slide, but now when we arrive at these steps, when it comes to derive this bracket, we are going to derive it with respect to y, because we are actually solving this question. So we are we first derive the function with respect to y. So in other words, if I have the derivative of w with respect to y, so all these parts will remain the same. So you don't always have to do that from scratch. You can just see, you can just look at the part that need to be changed. So the part that need to be changed is this part here, because this part has a dash symbol, it has a derivative symbol. So now you are going to derive this expression here, but with respect to y. So we don't care about the x squared and the z squared, because if you derive these two, you get 0. So you only focus on the y squared. So if we derive y squared, we get 2y. And then the next thing is to get this. So in other words, you need to replace x, y, and z by this values here. So I'm going to have 1 over 2 multiplied by 1 square plus so the value of y is -2, so we have -2 squared plus the value of z is 1, so you have 1 squared then multiplied by 2, so y is equal to -2. So you just need to compute this and get the answer. So now for I'll recommend you to do this. So that's the first question. So if you can do the derivative of y with respect to z, and there are other questions that you can try. These are the exercises. So when you are free to solve, you can just go over all these questions. So it's basically 2 questions. So the first question is this one, and you're going to try this exercise. So next time I'm going to explain you so we've been doing the first order partial differential equation. Not differential equation. We've been doing the first order partial differentials. So next time we are going to do the second order partial differential, and then we're gonna also see some application on that, and then we're gonna finish with the partial differential section. Yeah, so just take time to go over all the explanation and also try to practice this question. And you can send me the resolution via WhatsApp. I will just check, and then if there's something wrong, I will let you know. Cool.